Pre-lesson, section 3.2, day 1. It's called Sum and Difference Identities. So just so you know, you're going to be hit with a million formulas in this class, and you're not expected to have these memorized. These are just exercises, if you really want me to be honest, that force you into practicing your 30, 60, 90 rules, your 45, 45, 90 rules, also your quadrantal, sine of pi over 2, sine of pi, sine of 3 pi over 2. Excuse me. So think of it that way. These formulas are just different creative ways to get you to practice the rules you're supposed to be getting really good at. Think of it that way. So you're going to be asked to manipulate these formulas and be a little creative with them, though. So with that being said, examples 5, 6, 7, and 8. As you can see, I've identified them, 5, 6, 7, 8. That's where the real nitty-gritty, that's a line from Nacho Libre. This is, and I've got one example ready to go, and I'm going to finish that for you. Examples 1, 2, 3, and 4 in your packet are just going to be warm-up. So I'm not going to spend much time on those. I'm going to trust that you'll get it, and we just do the packet lesson. They're pretty simple. But then when you get to these examples, they get a little bit challenging. And here's your golden rule for this section. They're going to have you manipulate these formulas with a problem like this. Now, with that being said, I have 105 degrees right here. And they're going to ask you to use the sum or difference identities, which just means, hey, use one of the formulas that works. But here's your goal. You're going to use 2 degree measures to replace this 1. So I'm going to put an X through that. Something that equals 105, like 104 plus 1, or 106 minus 1. Now those wouldn't work because, look at this rule. You got to use 2 degree measures using plus or minus to create the original theta. Now the theta, this could be in terms of degrees. It could be also given to you in terms of radians. So be prepared to convert radians to degrees if necessary. But here's the huge hint. The 2 you choose must result in 30, 60, or 45 degree reference angles. Now don't forget, a reference angle is when you spin the spinner and it goes up to here, that would be your reference angle. Or if you spun it to here, that would be your reference angle. So you could pick something greater than 90, for example, 150. That could be one of your angles you pick because your reference angle will result in a 30 degree reference angle. So that would be a good option. But there's a lot of good options. You're honed in on this problem to create 105, somehow using angles that will result in a 30, 60, or 45 degree. Now look, reference angle. I didn't say you had to pick 30, 60, or 45, because look at it, I said 150 is a good selection if ever it works out for you, because it results in a 30 degree reference angle. Now for this first sample, 105, I'm going to concentrate on plus because something's already jumping out at me. Look at it. What's 60 plus 45? Well, it's 105. So I'm going to go 60 plus 45. Now a lot of students say, well, what if I went 45 plus 60? Don't worry about it. The formula will take care of it for you. So the order doesn't matter. What if I wanted to use minus, or something popped out at me and I said, okay, hey, I'm going to subtract 45 from something. Well, that would be 150. Now, I didn't do that on purpose. That was actually kind of totally random, but it worked out. Minus 45. Student number 1 could use this. Student number 2 could use this. Student number 3 could switch these. Now, you couldn't switch these because you'd end up with a negative 105. So you're stuck with this. But these 2 you can switch. Now, here's the thing. Here's the formula. Sine of u, that's the first thing that comes. So this is my u and that's my u. plus v, so in this one, this is my v, but if it's u minus v, the second thing is also v. So that's a pretty simple rule. But if student number one comes along and they say, hey, I want to use this one, then they have to follow this formula. So I'm going to plug things in where they belong. So I'm going to get sine of u, which is 150, times cosine of v, which is 45, minus cosine of u, which is 150, times sine of v, which is 45. Now the next student that uses these two, they're going to use the sine of u plus v formula. So they're going to use this. They're going to go sine of 60, got to stick with this, cosine of v, which is 45, plus cosine of u, which is 60, sine of v, which is 45. Now, just to save a little bit of time, I'm only going to do one of these. So I'm going to do this one. And I'm going to do it right over here. What do you mean, do it? Well, the instructions say, for examples 5, 6, and 7, it says use a sum or difference identity. See, we just did that. To find the exact value. What that means is, when you get to here or you get to here, you're not done. These are not exact values. You got some work to do with your spinner. You do some calculations. Now, examples 1, 2, 3, and 4, way simpler than this example that I'm showing you. So on this problem, I need to spin my spinner 150 degrees. Be accurate, you guys. In other words, if this is 90, this is 60. Don't make your drawing look like a 45, 45, 90 if it's not what it is. So that leaves me with a 30-degree reference angle, which, if I look at it, this is my 1, so this is my 60, so this has to be negative square root of 3. This has to be 2. And I'm going to find sine of 150 degrees, which would be opposite over hypotenuse, so there's 1/2. I do need to find cosine of 45, but I'll get there in a minute. Minus, now look what else I got to find. Cosine of 150, so cosine would be negative square root of 3, that's my adjacent, over my hypotenuse. So that'd be negative square root of 3 all over 2. And now, because these are 45s, I need to draw myself a 45-degree reference angle. In other words, spin your spinner 45 degrees up, bing. And of course, that's going to leave me with a 45 reference angle, which according to this rule is good. And now I got my 45, 45, 90 with no dimensions. So we're just going to go with a simple 1, 1 square root of 2 and do our calculations. Cosine of 45, adjacent over hypotenuse. Sine of 45, opposite over hypotenuse. And now it's an algebra special. Hope you're paying attention to your algebra 2 teacher. What do we get here? Well, if I try to cross reduce, I can't. So I just swoosh, which means multiply straight across. Now, this minus and this minus would definitely cancel. So it's going to be plus. And I'm going to try to cross reduce. I can't. So I swoosh. Square root of 3 all over 2 square root of 2. Now look what happens. Something cool happens. For a math student, math teacher, you're like, yes, you got common denominators. So I'm just going to add this stuff in the numerators. You know, this is no different than 1/7 plus 1/7. That'd be 2/7. Your denominator doesn't change, so don't make it change here. So I get 1 plus the square root of 3 all over 2 square root of 2. The last step is this. Now again, remember, especially here in our class of pre-calc, if it's 30, 60, 90s or 45, 45, 90s, which these are, you're expected to get the radical out of the basement. By the way, good parenting skills too. Don't let radicals stay in your basement. You know what I mean. So I'm going to multiply this by the square root of 2, square root of 2. I'm going to distribute, so I get the square root of 2 plus, look at that, the square root of 6. What happens here? Well, the square root of 2 times the square root of 2 is the square root of 4. Square root of 4 is 2. 2 times 2 is 4. And no, you can't reduce that. It's a very strange looking answer. And there it is. That's how you manipulate these and play around with them. Again, what's the goal? Honestly, to get you to mess around with these and these, and then practice your algebra.